Substances, materials, and technologies represented in this video exist beyond the laws of physics. They exist in spite of them and astound reality with their mere existence. However, they are all definitely real. The most incredible of them, as usual, we saved for the last. Let's begin with europium, a metal that belongs to the lanthanide class in the chemical elements chart. They all stand apart due to their unusual properties. But europium, even among them, looks the most bizarre. First of all, this element has abnormal chemical activity. If you put it in water, it will immediately dissolve in it. But europium isn't eager to burn at all. It also behaves oddly when exposed to air. After a couple of days, it turns into an oxide powder, which turns red under UV light. Due to this, it is used in luminous phosphorus powders. Its particles are also used in the luminescent inks on Euronotes. And it is precisely because of europium that there is a saturated red color on screen. The other material with an absolutely unique nature is pyrolitic graphite. It consists of many layers of graphene. Although pyrolitic graphite's nature is vastly different, it's a perfect diamagnet. Rather, it repels the magnet stronger than all other materials. It doesn't matter which magnet pole it's facing. Here is a block of 9 magnets clenched together in a specific sequence. And above Tice block, a plate of pyrolitic graphite hovers. Of course, the levitation effect is achieved by means of the small weight of graphite, but if you take a larger magnet, then it will work out with a heavier piece of graphite. There is another unusual feature of pyrolitic graphite. It is the best heat conductor of all. If you take the slice and try to cut a piece of ice with it, it'll work, simply because the ice under the influence of heat will quickly begin to melt and split into pieces. And these are hydrophobic materials. Look at this square of green liquid. How does it keep its shape and doesn't cross the invisible boundaries? The fact is that the surface around the square is covered with this very hydrophobic material. If a water droplet falls on it, it will take on an ideal shape and simply slide down. This is the so-called Lotus Effect. Recently, scientists from Dubna City have learned to reconduct it on the surface of any material. They have achieved this thanks to modern technology, colloidal synthesis of nanoparticles. Atomic force microscope studies have shown that this hydrophobic nanorelief almost completely mimics the surface of lotus leaves, which naturally repels water droplets falling on it. And another research team from the University of Rochester has managed to create a hydrophobic material of such quality that water droplets simply bounce off the surface. A distinctive feature of this method is that the water repellent properties of the material are not due to the additional processing, but due to the very texture of its surface. This means that its properties won't wear off after some time. The range of applications for this material are endless. Who knows, maybe in a few decades we will have such multi-level pools. Although it's quite another story. We will discuss the possibilities of it a bit later, and now let's look at the water, and not just some water, but dry. The name alone may already blow your mind, but the nature of this substance is even more unusual. In the 90s of the last century, dry water was invented by specialists from 3M company. 3M still exists nowadays under the brand name Novec. Scientists used the formula of ethyl isopropyl ketone and replaced in it all 12 hydrogen atoms with fluorine atoms. The result is a substance unlike anything people have encountered so far. Today there are many variations of this substance, with different temperatures and densities. The most famous Novec 649 and Novec 1230 have a very high density, which is why their weight is much heavier than that of ordinary water. Another unusual property of this liquid is the feeble ability to moisten the fabric and any other fiber. Look, what will happen if the napkin is put into ordinary and dry water? In dry water, it practically does not get wet, and the remaining water simply drains from it. Also, dry water has a low solubility, hence the name. Dry water is also used in automatic fire suppression systems. Next on our list of unusual substances is hot ice. In fact, it is a liquid that becomes solid at the slightest impact on it. Hot ice, or sodium acetate from one touch, goes from a liquid state to an ice-solid crystal. Same patterns are formed on the entire surface as tracery made by frost on a window pane during frosty winter. When pressed, a crystal core is formed, from which information about the new state is transmitted to the molecules along the chain. Naturally, this substance only looks like ice. It feels quite warm to the touch, and is actually used to make chemical heating pads. Number 6 on our list is one-sided bulletproof glass. Ordinary bulletproof glass has been known for a long time. The outline of its work is the retention of bullets and the delay of the shock wave. But such bulletproof glass is useless in combat conditions, when you need to not only defend yourself, but also attack the enemy. And such glass is blocking bullets from both sides. But a group of scientists from the PAS company was able to solve this problem. The unidirectional bulletproof glass they introduced, on the one hand lets bullets through it, and on the other hand stops it. This is achieved by coating the glass with special acrylics. The key point, of course, is not to confuse the right side at the most crucial moment. And now let's have a look at gas that is able to hold solid objects. This is sulfur hexafluoride. If you fill a closed container with it, it will sink to the bottom because it is heavier than air. And if you put some small object on top, for example, a foil boat, it'll easily hold it on its surface. And if you scoop out the gas, then the boat will sink to the bottom. Another quality of this gas is the ability to reduce the frequency of any sound passing through it. And if you breathe in some sulfur hexafluoride, you sound like Darth Vader.
That's good.
Luke, I am your father.
On the 8th position of our chart is an object that fascinated even our remote ancestors is a Celtic stone. This rare object was known even to the ancient Germanic tribes, the Celts, hence the name. Today, archaeologists discover Celtic stones in various parts of the world. This is a knick-knack in the stern of an ellipse, which is designed in such a way that it can only rotate around its axis in one direction. In the opposite direction, the Celtic stone won't spin at all. This thing violates a number of physical laws, such as the law of conservation of angular momentum. The main secret of the Celtic stone is that the direction of its geometric axes and symmetries does not coincide with the direction of the axes of inertia that pass through the center of mass. Now imagine that matter itself begins to take such shapes as you want. We are already familiar with 3D printing, when, according to the established parameters, the printer gives us what we need. 4D printing allows you to create objects that can change their shape or structure under the influence of water, heat, light, or other factors. What happens to a thin strip of wood if it is moist on one side with water? It will begin to deform, but these deformations are unpredictable. Specialists from the scientific laboratory of the University of Massachusetts have learned to predict the deformation of the material, or rather to program it. It turns out to be a programmable matter. Scientists are making wood to take the desired shape by wetting the material in certain places. And look what happens. But researchers not only work with wood. A number of different programmable materials have already been developed. And now we would like to bring to your attention Gembez. Looking at this plastic figurine, you will never guess what unique qualities it possesses. But its unusual shape and composition is the result of solving a unique mathematical problem. Previously, scientists were sure that an object of this shape is simply impossible to create. We are all familiar with the roly-poly toy that always returns to its original position. This is achieved due to the fact that at the bottom there is a block, and on top it is empty. Two Hungarian scientists, Gabor Dimakas and Peter Varkonyi, troubled themselves and decided to find out if it is still possible to create such a homogeneous object, and they succeeded. Gembez is the world's first example of a three-dimensional convex body with one stable and one unstable equilibrium point, or a monostatic object. Gembez can be in one single state of rest. If you unfold it, tilt it, put it on the other side, it will always return to its original position. Initially, the existence of such an object was proved theoretically by solving the most complex mathematical equation. It took 10 years and a huge number of experiments to solve it. For solving this problem and for the Pyrolitic itself, the creators received many awards. Well, now some bonuses. Researchers have achieved from the atom in rubidium the behavior of matter with a negative effective mass. This means that these atoms, under external influence, did not fly in the direction of the vector of this influence. Experimentally, they behaved as if they ran into an invisible wall every time they approached the boundaries of an area with a very small volume. The corresponding article was published in Physical Review Letters. For example, scientists call the behavior of holes in semiconductors, which every user of modern electronics deals with, negatively effective mass. In general, as the rubidium atoms moved in the direction opposite to the vector of the force applied to them, the media all over the world trumpeted the creation of a substance with a negative mass, dropping the word effective. Imagine two masses placed next to each other. Negative mass is attracted by positive mass, and positive mass is repelled by negative mass. Therefore, both masses will experience the same acceleration forces, which violates Newton's third law. After all, such a system of two masses will infinitely accelerate. It seems like this is just a silly theoretical experiment, but in fact, scientists are very fond of such tricks. Not so long ago, an article was published in the scientific journal Quanta called "There Are No Laws in Physics." Its author is Robert Dijkgraaf, director of the Institute for Advanced Study, where Einstein spent 22 years of his life. Dr. Dijkgraaf writes about a frighteningly multi-divisional maze of possibilities, an almost endless network of loosely interconnected alternative versions of reality. Dr. Dijkgraaf writes, "If our world is but one of many, how do we deal with the alternatives?" The current point of view can be seen as the polar opposite of Einstein's dream of a unique cosmos. In his article, Robert Dijkgraaf writes about string theory. The result of this theory was a maze of mathematical solutions, in the amount of 10 to the 500th degree, where each solution corresponds to one of the potential universes. Some of these are ours, but this is not certain. But why did scientists need such mathematical tricks? The discovery of the mysterious force of dark energy, which accelerates the expansion of the universe, moving the galaxies apart from each other at an increasing speed. Dark energy has all the hallmarks of the cosmological constant that Einstein introduced into his equations, the century-old theory of relativity, but then abandoned. However, the experimental value of this cosmological constant differs from the theoretical one by 10 to the 60th degree. We'll get back to dark energy in future releases. Like and comment to let us know that you're interested. Well, that's all for today. Thank you for your interest in the topic and comments on point. See you on our channel.